All right, Sam. So thanks for leading our event tonight, and I'll let you just go ahead and kick it off.
Awesome. Thank you. Yeah, I am about to share my screen so we can all pretty much see my slides in a second. And let's see this. Perfect. Okay, can you guys see this?
Yep.
Perfect. All right. All right. So let me get things set up on my phone so I can have my setup going okay. All right, perfect. All right, well, thank you guys for coming. As I expected, I definitely cannot see you guys right now. It's just the screen. So, I'm gonna assume that silence probably means nods if I'm like, oh, does this make sense? But otherwise, no worries.
Yeah. He said his mouth is full too. So I'll make sure if anybody's got any questions and you can't hear them, I'll relay the message.
Okay, cool. I appreciate it. But yeah, thank you guys for joining. I'm Sam Portillo. I'm joining you guys from Richmond, Virginia tonight. I was supposed to be in Atlanta. However, I was down here for a company all hands. I have a rental property here, and I was bringing in a new tenant while I was in town for the all hands, and so his cats aren't getting along with the residential cats here. So it's kind of a tricky thing. I'm a bit of a cat whisperer, so I'm hanging around to make sure the rest of the intros go smoothly, so it doesn't, create problems down the road. But otherwise, I'm really looking forward to joining you guys in person, probably, hopefully, at your next event. I was hoping to have my company sponsor the pizza and stuff tonight, but yeah, the bill will be on me next time for sure. So I'm looking forward to having a drink with you guys then.
That's all right. I'm going to pass it on to my company, so we should be good.
Perfect. All right. So yeah, like I said, I'm Sam Portillo. I like to think of myself as mainly a friendly data engineer that, likes coming out, sharing knowledge and, shaking hands and meeting folks and just learning about the experience that they have to share as other hopefully data practitioners or solutions architects that work a lot with the cloud. Um, I also organize a meetup in the Richmond area for data engineering, and we launched it a couple years ago. Actually, we're coming up on 3 soon, and it says approaching 1,000 members. We definitely have over 1,000 now, and it's been a good time. I've met a lot of speakers and learned about a lot of new technologies through organizing this. And um, the reason I'm in Atlanta is because my company is actually launching a new office there. So I'm on the launch team, and I definitely want to get involved and plugged into the meetup scene here and get to know the folks here and start sharing knowledge like I did in Richmond. So yeah, I'm more than excited to start seeing some friendly faces and get to know some of the things you guys are working on. So a quick agenda for tonight is going to be we're doing pretty much an overview of Amazon Keyspaces, which is their Cassandra compatible data store service. And the agenda for tonight will basically be I'll be talking about Cassandra design for about the first 10 minutes, because you can't talk about Keyspaces without talking about the design of Apache Cassandra. And this is all open source Cassandra. DataStax has like an enterprise version of it, but we'll be sticking to pretty much the brass tacks of the open source version. Then I'll hop into Keyspaces and talk about some of the benefits that it offers as a cloud managed service, and also highlight some potential drawbacks. And then we'll finish up with a demo of a personal app I built. It's working with personal finance, and we'll basically go through the full data modeling process, and then I'll show what it looks like in action. Um, It'll be using Keyspaces as the main data store, and it'll have compute running on Lambda using Python and S3 for some storage. Cool. All right, so starting off with Cassandra design. Now, I'm curious to know. I figure most of us here are all like working with AWS at the very least, since this is an AWS group. But how many of you guys would you guys consider data practitioners or familiar with database technologies?
1, 2, 3.
Yeah. 3 of the 4 of us.
3 out of 4.
3 of the 4. Awesome, awesome. Have you guys ever worked with NoSQL, either just as a developer or any like system administration of infrastructure for databases like this?
Limited.
Yeah, extensive.
I have a little experience with DynamoDB.
Awesome, awesome. Okay, well, that's good to hear. Hopefully, we'll all be able to learn something tonight. And for the gentleman who definitely has experience, I'm more than happy to, learn any insight you have to share. Because I'm still learning this too. I think as engineers, this is something, is an ongoing
No,
process.
I know it more from an application development point of view.
Okay, awesome. Yeah, I'm definitely kind of in the same track too. I think the system administration part of it is definitely outside of, the scope of what a developer does, but it is good stuff to know. And I'll be touching on all of it tonight. So to start, Cassandra is a NoSQL database, and there are some differences between NoSQL databases and relational. And we'll kind of just go down the list. For relational databases, the methodology is starting with, the data, then they model, and then you build applications. For Cassandra, it starts with the application's needs first, and then the model, and then you get the data in there. For relational databases, a lot of their tables are entity-based, so schools, students, teachers. And then for Cassandra, it's more query-based, so based on the information you're trying to get out of the database, that's how the tables are defined. And in relational databases, the primary key is used for mainly uniqueness within the tables. And then for Cassandra, the primary key is much different. It's used for like the optimal storage and retrieval. And we'll touch on all of this stuff as we go through. I'll give more context and some visuals as to how primary keys are used for storage and retrieval. With relational databases, there's the single point of failure often. With Cassandra, it's more of a distributed architecture, data stored across multiple nodes. And again, we'll dive into this in a little bit. And with relational databases, they support joins and indexes. With Cassandra, believe it or not, they do not support joins, rather focusing on denormalization. And we'll see how a database can operate without joins, pretty shortly. So pretty high level overview of what a relational data modeling methodology is like. And, starting with your conceptual data model all the way on the top left, which is kind of just defining your entities and the relationships between entities. Say, for example, sorry, it's one of the cats. Say, for example, students, attend schools and whatnot. And then that goes into the relational logical data model. So this is kind of I don't want to call it like a pseudo, SQL, but this is kind of a high level overview of what the schema is going to be like. And then that gets normalized and you end up with your physical data model, which is effectively what ports over into directly like a create table command. But the thing I wanted to highlight here is that queries are considered pretty late in the game for relational data models, whereas for Cassandra, the queries are considered basically from the start. So you start off with your conceptual data modeling step again, but you do your application workflow like right at the same time for mapping to any sort of table structures. And the application workflow would be like, a user enters your website, they click on this video, they click on the comments, which would be for like YouTube, for example. And so that's how you start to kind of get your use out of your application first before focusing on the data models. And it's what drives, the data models for Cassandra. And this is kind of a summary of how relational versus Cassandra modeling starts, with relational being, starting with the data, then you model, then you consider the needs of the application. With Cassandra, you're designing your application first, and you let the needs of the application derive your models, and then focus on the data last. Any questions so far?
No.
Awesome. And again, this is also just kind of a, just contrasting, there's not like a one fits better than the other, or this one's better than that one. They're two technologies that have, different functions. And I don't have a slide for use cases for NoSQL, but I would say that like typical use cases, if any of you are interested in knowing, any, like logging data would be good. I think it's good for finance data, or time series data, even though we haven't hopped into actual data modeling and what a model looks like. But, it could be used, it really depends on the query pattern. I mean, I don't think that relational databases will ever go out of style, but this is just context for understanding, what Cassandra is. So in a traditional like relational model, you've got like you could have two tables existing and they join like so. They kind of interweave across the two tables to get a row from one table to connect with the other. And that's how you effectively get, data returned to your users. This works really well when your data is all stored on like the same node and it's all close by each other. Since Cassandra is distributed and data is stored across different nodes, it makes joins like difficult. And if you were to force that, because it can do it, it would just lead to effectively unpredictable latency. So for Cassandra, the way you would model something, kind of similarly is you would model it based on like the API access you're providing to your users. So say you have an app that you want to search like comments on like, I'm just using YouTube, for example, since we all probably know it. You can search comments by video or comments by users in this example. And imagine that's kind of coming from your access pattern to your API. And so for each one, you would define a different table that serves that exact purpose. And in Cassandra, their philosophy is that storage is cheap. So you're able to get away with redundantly storing, say, the comment column or the video ID column multiple times across different tables. And it's also important to note that you're going to be searching basically directly on the primary key. And for comments by video, that example would be just the title ID or the title, basically. So you would search for that title and get all your records back where the title equals insurgent, if that was your search for that one. Let's see. Other things to note over here, these are actual create table commands. Yeah, you define your primary key. And in this example, the partition key is that like first key that's inside of the parentheses of the primary key. And that's basically how your data is being stored. And I'll show an example of how it gets stored. So, these primary key, partition key, the terms can get kind of, confusing, but that's your search term, basically. Comment ID is associated there just to kind of provide some uniqueness. And it's a clustering key. I won't dive too deep into that right now. But I will provide a definition at the end. And so that's how you would perform multiple searches on the same type of data within Cassandra. And, I will say that even though it's stored multiple times, the responses because of this pattern are pretty blazing fast. So we will hop into that in a second. But just to kind of show off what happens when you search for like columns outside the primary key, these would not be possible in Cassandra. You'll end up getting an error returned back because when you define your table schema, it only allows you to search on your primary key column, which is why you need to define multiple tables with a primary key containing the same data if you wanted to search, by those search patterns. These are possible in relational system, but for Cassandra, you would not be able to search and then get the blazing fast performance that you would, by Cassandra's traditional search retrieval methods. Okay, so to kind of dive into an example of the storage structure under the hood, this is a pretty simple table with a single column for the primary key. And, primary key, partition key, are terms that are kind of thrown around. But the partition key would be like the way that Cassandra knows how to store it under the hood. And in this example, the primary key, definition is just a single ID column. And under the hood, when that is stored in Cassandra, this is kind of how it looks like. So you've got 1, 2, and 3 for your IDs, like your ID values for those rows. And those are effectively stored in their own kind of little blocks of storage under the hood when it hits disk. Let's see what is next. So yeah, as far as Cassandra is concerned, you take the primary key column, you search by that, and you get the rows that are retrieved that are within that partition. So if you're searching for 1, like partition equal, or I guess ID equals 1, you'll get that top row there and all of the attributes that are stored with it in that kind of cell. Does that make sense so far?
Yeah.
Okay, dope. Cool. So when you search on non-primary key columns, this basically enforces a search across all nodes, which is not very efficient. your nodes could be stored, in different clusters. Doing a search by each node is not efficient, of course. Whereas when you search on your primary key columns, Cassandra uses a hashing algorithm to basically locate where exactly that partition is located on disk. And so that's how it makes it so efficient, retrieving that very specific, those records from that individual partition. And honestly, like data modeling is very key in Cassandra. So making sure that you set this up correctly, making sure that it ensures that your partitions are balanced well. You don't have partitions that are massive that take up entire nodes. You ideally don't want like a full partition of data to be over 100 megabytes, but I even think that's a lot. And you can be like, you'll have to be clever about the way that you model. It takes time. You need to really understand your data. I've made mistakes creating tables that have like poorly picked partition keys, and it's led to serious like skew and imbalance on how data is stored under the hood, which it creates a lot of problems down the road. So let's see. Quick like recap on some of these names that I'm using. Primary key, partition key, clustering key. Partition key is just that's like the key that Cassandra uses to store the data under the hood. The primary key includes your partition key and your clustering column, and a clustering column would just be used to sort the data within a partition. So if your partition key was like, I don't know, if it was, I guess, say, like let's see, I'm just pulling up examples right now off the top of my head. I guess movie name. Yeah, if you had like a movie name, I guess partition key. And that's like, if you have Interstellar and you have Interstellar appearing a whole bunch of times, and then like, I guess like a time that was like set like for that viewing time at like a movie theater. So like a date time. So like, December 21st, 2012. And you have like Interstellar, Interstellar, Interstellar. That's all within the Interstellar partition. And then your clustering key would be the time that viewing occurred at that movie theater. And so if you had that as a clustering key, you would just simply sort on like the clustering key, either ascending or descending. So, when Cassandra goes to retrieve data for Interstellar, depending on how you define it, the first record it would retrieve would be the first showing of Interstellar or the last showing of Interstellar. Does that make sense?
Yes.
Yeah.
Okay, nice. I came up with that example just now, so yeah, I feel pretty good that my brain is still working at like 6-ish p.m.
Actually, that was a great visual
Yeah.
you gave, because I was just caught up in the visual. I actually know what he was talking about.
So Sam, being pretty new to NoSQL, if you wanted to retrieve the data a couple different ways, one by Interstellar, but maybe, I don't know, you needed to also be able to retrieve it frequently by length of the movies, and you wanted to see all the movies out there that were 112 minutes long, would you have to store the data twice under two different partition keys, one under Interstellar and one under 112 minutes?
Yeah, I'm thinking off the top of my head, if there's two different ways to search it, you would definitely need to do that. Potentially, if like I would need like a pen and paper or a napkin to do some, little math and design. But you can also search by length too. However, if you are more concerned about the lengths of all movies and your search pattern was just straight up like, let me like return all movies ever that are length 120 minutes, that could work as a potential search pattern. However, when I mentioned like having your partition in balance, like I would say that like in the course of like the history of all movies ever, if you were to store them all in a database, there's probably some magic number that filmmakers use that is like the go-to standard, which is probably somewhere between right, and that might create like a massive partition compared to all the
Gotcha.
others. Yeah. So you would have to be clever about doing that, which is where like understanding the data and domain really comes in handy. But I'll never back down from an honest challenge. So, maybe we'll reconvene next month and I'll have an answer for sure. So
All right.
this is pretty much where the scope of the developer ends with this one. The next slide is really like, what's that?
Before you, I thought you had more to that, but like before you move on from that, there's always at least from a performance point of view, there's always the point where you do something out of convenience or out of cost, right? And I can apply that same thing to programming for performance, right?
Mhm.
And data fetching and stuff. In a relational database, like it's the path, the execution path is pretty much very similar. You know, it's not much to kind of screw it up. I mean, not screw it up, but like improve it, right? Based on the way I'm getting to a point where my main problem is with the back end. So the front end, Cassandra produces good results and produces them fast using the storage structure you explained, right?
Mhm.
I'm trying to understand what's happening behind the back end on the machine level, because is it that like is there a performance hit on the cache in order to keep all that in memory before, you know, it's like what's the price for this?
Yeah,
Is my
that's a good.
I mean I went around a long way, but I was trying to get
Yeah.
to that point. Like what's like it's nice and all, but what's the I mean I've worked with Cassandra, but I never had
Yeah.
to think about it till the way you're kind of digging into it. So
Yeah.
like so
Uh,
it's there's
so
always a cost.
that's a good question. And so I think that the way to think about it here is, and this is honestly with any database methodology, the faster that your writes are, likely the slower your reads are going to be. And so the slower your writes are, chances are the faster your reads are going to be. The more time it takes a database to write something in a very particular way that optimizes it for retrieval, it's usually kind of how the offset works. And with Cassandra, I wouldn't say their writes are slow. You know, they claim fast writes, but Cassandra, like the way that they hash your partition and they find a very specific spot to put it, that does take time to put down and like commit to like the disk layer. Um, so if you want to think about it like that, where Cassandra definitely takes its time doing a clever write so that the retrieval is very, very speedy when your data is modeled correctly. That's really the offset there. And there's different ways you can store your data under the hood. Cassandra they have a guide on what EBS volumes to use for specific circumstances. I know that there's definitely a recommendation for like incredibly like quick retrieval. There's other ones that are optimized for I believe it's more like archive data. So like if you're storing log data, basically. Um, honestly, I hope that answers the question. But yeah, I would
No,
say that
it definitely helps soothe the concern, because like knowing you know the problem is sometimes we get caught up in the technology that we don't ask you know what am I paying for this, because it's always the
definitely.
shiny, like when you're getting into any tech stack, it's always the shiny most optimistic
Yep.
um you know question you're trying to get answered, but I like to know what I'm paying for that
Yeah,
convenience.
I'm with you. I'm with you. But also, you know, that 100 megabyte storage limit for each partition, that does make it difficult to store things with a partition key that has several like millions of records. Um, that does make things difficult. Like I remember I was storing some data regarding like domains. So every single like domain had like its own, you know, partition effectively. And for a domain with this particular data I was working with, uh, like google.com appeared way more than every other record. And I'm talking like I was in like the multiple billions of records being stored in one partition. And that basically broke my application. I was not able to store that pretty much naturally as it was. So I had to do some really clever thinking of the data model up front to get like good Cassandra retrieval performance. So there's definitely offsets. I would say that like having to design your data model very well is definitely an offset. Like with Cassandra, you can't mess around with that. Like you got to do a lot of development and research up front to be able to get the performance they advertise. So yeah, I would say that, you know, as far as data modeling goes and getting up to your, you know, application needs and your queries and your data up to that point, that's pretty much all the developers are really like, concerned with. Data modeling, building the tables, in SQL, and then loading it with data. Now, on top of that, managing a Cassandra cluster has a lot of like maintenance activities you need to do. To keep your cluster healthy, you need to worry about configuring the cluster from the start, like choosing the optimal EC2 instance, the optimal size, setting up like performance and monitoring to make sure, when your cluster goes down, configuring how to like set that up with the elk stack. Adding and removing nodes is tricky. Learning Kubernetes to provision and manage all of this stuff is tricky. Setting up backups, restore, and moving data. Don't even talk to me about, JVM tuning options. I'm a Python guy, and security on top of all of that. So these are activities that have to be performed when you want to keep like, a solid production ready database. And honestly, this is outside the scope of what most developers will ever touch with Cassandra. I would say that this is, if you're gonna provision your own Cassandra and host it, you definitely need like a dedicated system administrator who knows how to set the stuff up. However, since we are cloud users, we don't have to really worry about that all the time. Just kind of rephrasing some of the challenges that I just brought up. You definitely need like that specialized experience to deploy, configure it, and manage it. Like you do need a system administrator who knows how to provision servers and manage them and monitor them. But you also need someone who knows Cassandra very well, because depending on the data you're working with, that might change the EC2 instance type that you should be using under the hood, the sizing of it, how much EBS volumes you should have. It gets pretty complicated when it comes down to it. Scaling clusters is tricky because then data has to, like, since it's distributed and there's data all over the place, it has to basically reshuffle and stream that data back to other nodes. Version updating is difficult. Restoring data is also difficult when something crashes mid-load or you lose a node, in a pretty destructive way. And having to keep everything updated and maintained well is also its own kind of art. So, I'm sure you guys know where I'm leading with this. Amazon made their own service to basically abstract all of the maintenance and management activities that you usually need to do, where now you can just focus on developing, creating your tables, and having like the benefits of the cloud, models that Amazon has with all their services, the super high availability and integration with all their other services. And a traditional Cassandra architecture would look, something like this, where you've got, all 4 nodes, and you reach out to a node, you interact with it, you get your data back, and that's that. With Keyspaces, you're going through Cassandra's like Keyspace sort of API, or any sort of interface through there, and that they abstract the way that it's all like stored under the hood. You're not touching any servers at all. They do provide you with an endpoint, but Amazon abstracts all of that to you, so you can just create your data, your tables, your Keyspaces, write to them, and then retrieve data. And by the way, Keyspaces is actually the name that Cassandra uses for their notion of schemas. So with Postgres, with honestly like most database tools, you have like schemas that tables are within. But with Cassandra, they call it Keyspaces. So that's why Amazon named their product that. Cool. And just the high level benefits here. It's obviously compatible with Cassandra. So, you can go ahead and port your CQL code over. CQL is what Cassandra calls their query language. It's Cassandra query language. So, and it's literally a C followed by a QL. You can port your code over there, create the tables the same way. No servers to manage, which is really, really big. Not having to deal with that. It saves quite a bit of time, in my opinion. I mean, like when I managed Cassandra on my own as a developer, that was like 90% of my job. And, as a data engineer now, that's like the way that people used to talk about data engineers with data scientists, where like data scientists would spend 90% of their time like focusing on the data prep, the cleaning. It feels like, they're solving the same problem here, where now as a developer, I can just focus on developing and getting my data in there and not having to worry about, managing, the infrastructure, balancing things. It's got the performance that, all the other AWS apps have. The scale I'm not too familiar with, because, Cassandra does kind of work a little funny again, when you start to have imbalanced partitions. So that's something I can't really speak to myself. I would love to stress test that one day and see how it performs or how it performs. But, again, it's also highly available, secure, pretty much accessed by any app. And I have not seen it go down yet personally, and I've used it for a minute. So that's nice. Okay, what is next? Oh yeah, well, okay, I could have just gone to the next slide and talked. I guess I talked through my points on the summary slide. But what I guess I missed earlier was it does work with most of like the open source Cassandra drivers and tools. So I personally interface with this all the time through Cassandra's driver for Python. And I've worked with a handful of other Cassandra tools as well that like interface with your data. One sec. So yeah, I'm sure that they work seamlessly as well. But my preferred one's Python. That's the one we're going to be using tonight in my demo. And like I put an asterisk next to this last point, and it's they say it appears to be on a 9-node cluster. I've worked on Cassandra clusters that are a lot bigger, or to match basically the scale of data I needed. 9-node, I think, gets the job done for most folks. That is a pretty big cluster itself. And I mean, imagine you've got 9 pretty beefy EC2 instances. Otherwise, that would need to create the same level of performance. So it does save quite a bit of money in that situation. But again, I need to check that because their documentation is a little unclear on how, how they're set up. I'm assuming they're virtualizing it under the hood, but how that translates into performance versus an actual manage, or I guess you're managing it yourself, Cassandra server. So when it comes to like the abstraction of responsibilities, the right side just kind of highlights it. You're just worrying about your key spaces and tables. All of that other stuff, the JVM, garbage collection, like the actual storage of like the disk stuff, like EBS volumes, your EC2 instances in the overall cluster and where it's located, they abstract all of that for you. So you can, again, just focus on, building, data and models and loading it. Now I will like highlight some drawbacks. I think there's pretty much any drawback to any service out there. And this is just for me working with Cassandra for so long. What I would say is these are potential drawbacks are it feels that there's limited flexibility when it comes to tuning. Cassandra has so many things you can tune. I mean, like there's a lot of situations and they have a lot of documentation like recommending how you should tune things based on your situation. Keyspaces they do abstract a lot of that out. So you don't really have to worry about it. For the most part, like folks won't be touching any of these default like levers, but yeah, they do abstract a good amount of it. So you pretty much just get pretty limited, tuning capabilities. As much as I'm raving about being able to not worry about servers, at the same time, a potential drawback is not being able to manage the servers underneath. Because for certain situations, you definitely do want to have that flexibility where you're choosing the EC2 instances under the hood. You are, picking your like replication strategies by yourself. You're managing how much EBS volumes under the hood. You're choosing like the number of instances that you got. Sorry, my cat almost fell off this tree. That was kind of scary. It's a floor to ceiling cat tower, so it's kind of tall, And after about
I saw some motion back there. So.
After about a second or two of cats falling, they pick up a lot of speed, So that was interesting. And anyway, though, as far as managing like servers, yeah, some people definitely would prefer the option to manage a server themselves. It's kind of just a question I have because I mean they're so finicky, like in your application is so dependent on the correct tuning. But again, for the most part, I would say that Keyspaces definitely gets the job done. And the last point I wanted to make about a potential drawback is like something you should consider is if you end up in a situation where you do have staff on hand that have the resources and capability to be system administrators for Cassandra, is that even worth it at that point? Yeah, I think it really depends on the use case because you would be saving a lot of money by moving to Keyspaces, running workloads on there. and effectively, saving a system administrator from spending, half of their week managing Cassandra. So it's stuff to think about. Any questions so far, by the way?
In terms of AWS costs, is it cheaper to run it using Keyspaces?
Man, that is a good question. There's definitely like an inflection point. I think for most use cases, it's definitely cheaper to run it on Keyspaces. I'm running a pretty lightweight app right now, and I'm still in free tier. Like I've never had to pay for storage on there or retrieval. You definitely have to pay something after like a certain number of like requests and storage per month. But I mean, after 2 EC2 instances, you're out of free tier. So
Sure.
yeah, I would say for the most part, you're good to run most apps on Keyspaces, and you can run quite a bit on free tier, in my experience. So yeah, that's my recommendation for you. And on top of that, if you're managing Cassandra yourself, you also got to run it on EKS, so Elastic Kubernetes Service, and learn Kubernetes. And so that's, you're already dealing with a handful of servers right there. So
Sure.
yeah, the cost racks up pretty quickly when you're managing hardware. Any other questions? How am I doing on time, by the way?
You're good.
1 sec. There we go. Okay, awesome. So this last piece will be the demo. Probably run for about 10 minutes, and then I'll open up the floor to questions. And yeah, I would love for you guys to pick my brain on any of this. So in this example, it's a personal finance app that basically just retrieves data from an API. It conforms it, and then it stores it in Keyspaces. What I need to do here is I need to model the data based on the queries I'm interested in performing, so that Cassandra sort of methodology where you figure out the needs of the application, and then you do the modeling, and then you get to the data. Now, the funny thing is here, I wrote this application without following any practices for modeling. So when I wrote this presentation, I went back through the app, and then I fully modeled it. Well, I modeled it for the most part, and now that's what I'm presenting now. So I hope it's interesting. It was interesting for me to step through the app and do that. However, I wrote Python code basically to talk to the API I'm pulling this data from, and then writing it to Keyspaces, and it's deployed on Lambda. So we'll step through all of that. And then I've also included an option to bulk upload some data from S3. So drop a handful of files in S3, it fires off a notification that triggers a Lambda that stores the individual files into Keyspaces. And then we're going to play around with some retrieval, and we'll see how quick some of this data returns from the Keyspaces console. So starting off with the data modeling portion. So top right corner is kind of that Cassandra data modeling methodology that we had earlier. Starting out with the conceptual data model. This is what, a very simplified version of what my data looks like. It is a point in time poll of specific tickers for some crypto data. And that the central like bigger oval is like the entity itself, and the smaller ones are all attributes. So you've got the important ones: price, ticker, and date, and then a handful of other statistics that I'm calculating behind the scenes. And honestly, like, this is an incredibly simple like entity model. I'm sure you guys have seen entity models before, where you have entities relating to other entities. So like that school example I gave earlier, you could have a student in the center, and then you have another entity that's school, and then you have a relation between the two that defines how they relate to each other. So student attends school, school contains student. And they get pretty big and complicated, but for this application, it's incredibly simple. There's one entity with a handful of attributes, and that's pretty much it. The next piece for modeling, the application workflow part, this is when you decide, you figure out the needs of your application and how you want it to act. So the single need of my application is, what are today's prices for a given ticker, right? And so your access pattern would be basically just pull that specific ticker's data for a specific date, and that's it. And this is called a Chebotka diagram, by the way. This is people use this to model how their website is gonna work. So for YouTube, you probably log in, and then you have the option, and that would be Q1, and then Q2 and 3 and 4 would branch off of that, and it would be like, you know, log in, access a video would be Q2, or Q3 would be, you know, go to settings. Q4 could potentially be go to a channel, you know, go to someone's YouTube channel. However, for this one, you know, it's just a single search. Any questions on this? Does this make sense? The next piece would be mapping from your conceptual model to your logical model. And the logical model, the output of it is kind of a pseudo schema, super lightweight, kind of just back of the napkin representation of what your data is going to look like. So I take that one axis pattern to pull a ticker's data for a specific date, and I've distilled it down into a very crude Cassandra table. And so you've got your columns on the left-hand side that are represented by, you know, the attributes of the entity earlier. And then the ... just indicates the rest of the columns in there. And then on the right-hand side, you've got the indication for what the column does. So the Ks mean that these are two keys that are going to be searched in Cassandra. And we didn't talk about this earlier, but this is a like multi-column partition key. So you need both of those search patterns to search and retrieve records for you. If it was a clustering column, it would have a C next to it and an arrow indicating which way, whether it's sorted ascending or descending. Cool. Everyone following along?
Yep.
Awesome. And then after this, the physical modeling portion is when you take your logical model and then you add data types and you know, official column names, and that's how you get your physical data model. So, you know, all we did for this one was basically just add the data types, and this one's pretty much good to go. I mean, this could be also represented with your create table command. And if I could find the create table command I used, I would pull it up, but I was looking for it and it's lost somewhere on some EC2 instance in a dungeon somewhere. But I got something that works just as well. And let me just see. I think this should be the end of my slides. Yeah, this is the end of my slides for this. And now we'll go ahead and hop over into the console and start to work from there. But and I think I'll be able to see you guys now. Nice. Okay, cool. All right, so let's see. This is the console. I can't see you guys now. Shoot. Oh, well. More screen for you. So this is the console. This is Keyspaces. We'll just go to the dashboard real quick just to kind of look at it. You know, pretty standard AWS console, but I am going to step right into the tables so I can show you this specific table that I made. And if you want to think of your physical data model as sort of this representation right here. So I've got two partition keys, the ticker and the date that this data was pulled. I actually have one clustering column. It looks like I seem to have omitted from the slides, but I use timestamp. Oh, that makes sense. I use timestamp within there so that I can sort my data within each date. So it returns it in order. So I can so I don't have to like sort the data myself when I go and process it with Python. And then here are the rest of the columns here. It's just a handful of you know, additional metadata that it's kind of pulling. Well, it's not really metadata. This is actual like data, but this is data it's pulling from the API as well. So ask price, bid price, close price, high price, and then a handful of statistics that your boy, you know, does very bootleg on his own because I'm definitely not a statistician. I took some classes in school, but yeah, this is some stuff I made up. You know, just doing some pretty simple SciPy, you know, code. And so this is the table definition right here. Now from here, we'll go ahead and hop into Lambda. I'll show you guys the code that interacts with this and writes to it. And then we'll go ahead and start to retrieve, we'll start to play around with some of this data. So I'm gonna hop into over here. So this is a step function that I have that pulls the data every 2 minutes. And what it's doing is a step function, by the way, is just a kind of like it's like an orchestration tool that runs and executes AWS resources. And, you know, it follows a pretty logical pattern. So, you know, it starts off, it calls the Lambda, it manipulates some of the response from it, and it mainly just checks to see if it errored out. And if it has not errored out more than 3 times consecutively, then it'll enter a wait for 2 minutes and then go back and hit that Lambda again. And the Lambda is just pulling, it is just pulling data from the API, conforming it, and then writing it to Keyspaces. This is the third time in like the last 30 minutes I've had to log in. That's what happens, I guess, when I'm using a private browser. I don't really know why. We should be good to, let me just log in real quick again. What do you guys think so far?
I think everybody's quiet because they're learning and thinking.
They're learning and thinking. No, quiet is, it's not a bad thing. Yeah, no, it's good. I mean, you guys are asking pretty good questions, and you know, that's more than I can ask for, so I appreciate it. Apologies for the world's longest password. Oh, that 1 second. I know this is right.
Is it password 3 times?
Is it password
No,
3
it's
times?
It's password 1, 2, 3, 4.
Yeah.
Password 1, 2, 3, 4, 5, 6, all the way basically through 20. That's
Using that Wi-Fi password, it's 1, 2, 3, 4, 5, 6, 7, 8, but it's 1, 2, 3, 4.
It's torture. That's torture.
That's
One of my
interesting.
friends have that one. So
Really?
it's like 2, 4, 4, 4, 5, 6s, and
Yeah.
All right, so I have some bad news. Apparently, Python 3.7 is not supported in the code editor, but you know, I don't take no for an answer. So let's see. Oh man, I don't have the VM on this laptop. I have a laptop behind me that has that's where I edit my code. But I also don't
Can
have,
you just view the code? Just
you can't view it. It's
no, not okay.
it's crazy.
Like a plain text. You can open it in plain text.
Well, it's not on this computer. It's on
Oh,
it's on the computer that's right over there. If you give me a second, I can join, or I'll actually just airdrop the file over here, and then we'll take a look at it in VS Code. This is called testing in production. 1 second.
this is probably a dumb question. Y'all probably noticed. Is Cassandra just that much faster than a relational database for an application standpoint?
depends on which relational database.
Well, I'm just trying to figure out why people use it as opposed to, because I mean, I've been using SQL for forever.
I still use SQL.
Yeah, I know.
Yeah. And you know the performance from one SQL database is different from another
Yeah,
one.
totally, depending
And
on.
so in
many
that
things.
context, it's not that much faster,
So what's the?
especially when you're considering joins. So like, obviously, if there's a lot of redundancy going on, when you're joining, there's going to be a lot of
Sure.
inefficiencies.
So I mean, I could see, I'm guessing the use case is if you're doing something like a full CRM tool or something like that, where you've got tables
No, it's
everywhere,
yeah.
you're gonna probably be more inclined to use SQL, but if you're trying to do something where it's
So it's meant
single
it was
transaction.
yeah.
I
It was
don't
built
know.
for like a friends of friends type data model. So basically, Facebook was one that kind of stretched Cassandra to what it is right now. So it was built for like more loosely held data.
Yeah, because I know you can
Yeah.
store things kind of on the fly to a degree.
Yes. And so like the risk associated with it is you can't guarantee data. So you can't be using Cassandra for serious, like a bank.
Yeah.
That'd be a bad idea because it's like that data redundancy also means potential data corruption. So it's not meant for applications that it's not meant for, I mean, it's obviously you can use it for that, but it's not perfected for applications that require high data accuracy.
Sure.
Also, in SQL, you have ACID transactions
Mhm.
where if something goes wrong, it rolls back.
Mhm.
You can't do that in Cassandra without data data retrieves.
Hmm.
Yeah. Or maybe you can do it, but maybe I don't. I just haven't gotten to that level yet. It's not as simple as just
Okay.
what
Apologies for
simple
the
does right now.
apologies for the technical problem, but we're back in action, and this is the code. Let me just change it real quick to a Python file. I was so lazy that I just copied the text into like the first file I had open, which is a JSON file. So let me see if I can rename it real quick so Python can pick it up. Bang. VS Code, come on. All right, well, I'm going to pretend like we can actually see it. You guys can see my screen again, right?
Yep.
Yeah.
All right, perfect. You know what? Hold on. Let me truly rename this. Because if I do this,
The issue is probably your OS on that machine. That's probably the issue.
use.py. Okay, perfect. Open this back up. There we go. Okay. All right. Well, it looks like my linter is still not really doing much. Oh well. The point is though, let's see. Yeah, inside of here, what it's basically doing is let me find the Cassandra code is the most interesting here. The rest of it's just kind of like, you know, the app operating. So you'll see that I need to specify, you know, all of this extra info here, and you know, just to kind of set the stage to connect to Keyspaces. I'm going to pretend like my authentication stuff is not there, but it's not the end of the world. But basically, it's, you know, this is the host name for connecting to it. You know, I initialize some SSL context. I have a private like certificate file that Keyspaces provides so I can connect there. And again, you know, I'm using the Cassandra driver from DataStax themselves, which is the enterprise version of Cassandra. I think that a lot of Cassandra contributors also work there. So they, you know, it's a pretty reputable company for Cassandra. But I use their Python driver to connect to Keyspaces, and you know, pretty much set all that authentication stuff. I connect to it, and then down here I take a payload that's you know, that's conformed pretty much upstream of this inside the Lambda code, and then I run this query right here that inserts it for every single column that I've got. It maps it from this JSON payload that I've got up here, you know, specifying each of the, you know, the columns. And I'm actually using an in-house Cassandra method to generate the timestamp column that I'm using to cluster. So it just uses, you know, to timestamp right now to just kind of signify when the data was written. But that is pretty much it as far as the Python code goes. Any questions?
No.
Nope.
The transformation process is pretty complicated because it's like an app I built when I was playing with some crypto data, but it stores it pretty quickly. I think I have some retrieval time or some write times somewhere, but the important thing is we're about to query some of this data now. So if I have a query table, so if I do this, now since this has been running for like the last 30 minutes, I should be able to pull any data for today for pretty much any ticker that it's searching for. So we'll go with Bitcoin because that's like definitely in the list. Ticker equals BTC. Date equals 2022, it's 29th.
Yeah.
All right, let's run that. And I'm going to do a limit 10. See what we got. Nice. All right, so execution time, 23 milliseconds, super, super fast. And this is the data that has been pulling back for like the last, you know, what, like 30 minutes or so. You know, as we've all been like sitting here. It's got timestamps for, you know, it running every 2 minutes or so. It's got quite a few attributes. I mean, it's actually a decent amount of data. And you know, the retrieval time, as you see, is super incredibly fast. The search that it used to retrieve this was it's storing it on disk using a combination of BTC and date, and Cassandra's hashing that to find the right spot on disk to go ahead and store this data at. And then it's sorting it by the clustering key. And so as you see here, all of these are clustered and like sorted appropriately. So it looks like this is stored in the I think that's descending. I don't know, but it's all sorted. That's the point. I'm gonna take off that limit and actually see how much it'll return. 27. All right, nice. 22 milliseconds. Pretty quick. And there's a lot of data in this table itself. If I were to do a select all from this table, it would just spin its wheels. It would take a while, which is why like the concise queries are the best for this example. I was going to show some data being dropped into S3 and dropped in here, but I think I pretty much got the point across. If you guys would like to see it, let me know. But it's almost 7:10, and yeah, I'm pretty much good to wrap up here. Pretty content with this so far. So let's hop to this slide. So, any questions, folks?
I'm from the infrastructure side or the sysadmin side, so I'm going to ask you a question about security stuff. For one cluster, you can certainly create multiple tables, etc. Is the access? Can you control access to the table by IAM directly, or that's something within the Cassandra itself need to be defined?
So access to you're asking if access to tables is defined by IAM and like restricted, the role-based access, basically assigned to users like that?
Yes, as a exposed as part of as a visible resource on AWS side versus internal to Cassandra cluster itself.
Yeah, that's a good question. I'm not actually sure. I think that, I haven't played around with role-based access for Keyspaces, but I think that they do expose it at least at the Keyspace level. I know for a fact that the pricing model, so either on-demand or provision capacity, is determined at the Keyspace level. So all the tables will kind of inherit those pricing rules. So I would assume that something similar would go for IAM. I would need to double check though, but that's a good question.
I guess my thinking is more from carry over from a work discussion on Redis. We have over 20,000 microservices sharing or supposed to, or potentially can sharing a Redis cluster, but so far they are creating one cluster each, and Redis just so the pricing model charge per cluster has the overhead by itself. Plus, there's each one of them are not as the aggregate. They can probably better use the resources, CPU, memory, etc., than each on their own as well. And the Redis certainly has the capability within Redis of its own language to define SEO, etc., to define. But I'm certainly not familiar with Cassandra.
Interesting.
The other question, I guess you kind of touched upon already, is any, I guess, AWS managed service, just like anything else. I want to make a service, I will take out certain features I'm not there yet, or I decided it's too bothersome for me to do, or it's too dangerous for me to expose. Either way, for Cassandra, what are the things you experience you wish it's there, or you hear from your customers they wish it's there?
Yeah, I personally would like the ability to like tune the cluster size underneath the hood, because I can't see the cluster. Like a lot of my debugging issues when it comes to balancing my partitions is directly affected with being able to see the cluster underneath, being like, all right, I can see where my nodes are. I can see where the problem's starting from. I can take a look and see how, like, I can measure the exact skew of my partitions if there's a partitioning issue, like by being able to like have shell access, to Cassandra. You do lose that feature with Keyspaces, which is, I would say, probably the biggest thing I would think about as like a feature that you'd lose by going to a managed service. But at the same time, those are really only scenarios you encounter when you hit really, really, really big Cassandra clusters that are almost like pushing the limits of, what the tool is able to do. Still really important to have though.
Yes, I mean, if we use eCase as example, the control plane is fully managed by Amazon, and you certainly has the capability to add data nodes yourself. Does Cassandra or Workspace follow the similar notion? The main cluster the key pieces controlled by Amazon, but provide additional ability for you to basically provision your own additional data nodes, if I may.
Yeah, Keyspaces does not have that capability.
Yes, to your early point, if you're pushing the envelope of the cluster's capability, such enterprise more than likely will have in-house staff to scale themselves. Like in case cluster, for example, where Citibank's running 500 clusters globally in their own data center, they probably will not need to manage the service anyway.
Wait, hold on. But I think I might have missed the question if there was one in there.
Now it's kind of commentary to what you said.
Okay, cool. Cool.
Thank you very much.
Yeah, you're welcome. Gentlemen, thank you very much for attending. You know, I'll be online. It's almost, 7:30, so I definitely want to let you guys get home and enjoy some beer and maybe your families or some TV. I don't know if you're into sports or anything like that, or wings, because you guys are in Atlanta. Everyone in Atlanta likes wings, right? Yeah. So yeah, this has been great. Definitely reach out to me on LinkedIn. I'll share the slides with you guys so you guys can have access to them. And yeah, let's stay in touch. I'd love to, keep nerding out and see you guys at the next event, hopefully.
Yeah, thanks, Sam.
Thank you.
Appreciate it. I mean,
Thanks, Sam.
I'll update the next one. I think I've got a speaker lined up for the July event, so hopefully I'll get something online soon. But I appreciate it, Sam, and hopefully you can get those cats under control.
Hopefully, they're all sorts of stubborn.
All right, thanks, Sam.
All right, folks. See you guys.
Again.
Bye.